Last class we have seen on-off based AC voltage controller. Okay, so RMS of the load voltage, RMS of the load voltage is or RMS values of the load voltage is VRMS of the source voltage, RMS values of the source voltage into root of n by m plus n. Here n is number of on cycles, m is number of off cycles. Okay, so in this case, for example, in this picture, how many, what is the value of n? N is 1, n is 2, n is 3. So n is 3, then m is 1, 2, m is 2. So n is 3 and m is 2. N is so n value is so n is 3, m is 2, so plus again 3, so this becomes 3 by root of 3 by n is 1, 2, 3, m is 2, root of 3 by 5. So what is the k value? K value is nothing but root of 3 by 5 for this particular picture, So if you want to calculate, so RMS of the load voltage means RMS values of the voltage whatever we have delivered to this load. So we call this sometimes as V RMS values of the load. In textbooks he called it as VRMS of sometimes we call it as output. Okay, so out or output. So sometimes we call this as VO. We need to understand that this is depending on the textbooks. We can use, main thing is we are calculating the RMS values of the load voltage. We can use any of these notations, Okay, so VRMS of the output is VRMS of the source into root of K. Okay, so I think this we understood. We'll solve some problems here. It is there in your textbooks. Okay, so an AC voltage controller has a resistive load of R is equal to 10 ohm and the root mean square value of the input voltage is 120 volts, 60 hertz. Main important is R is 10 ohm. Input voltage RMS value, that is source Vs. He has given root mean square RMS input voltage means source voltage RMS is 120, frequency 50. Thyristor switch is on for n is equal to 25 cycles and off for m is equal to 75 cycles. Determine the RMS of the output voltage V0. He called as V0. Okay, he called it as V0. So we will continue. So instead of VRMS load, he called this as a V0. He called this as a V0. So VRMS of the source is how much? He has given already 120. He called this as Vs. Okay, and root of n is how much? 25. N is 25. M plus n is how much? 75. 75 plus 25. So this is how much its value is 120 into 75 by 100, 25 by 100. This is 120 into 0.25. 120 into 0.25. This is 120 into root of 0.25 is 0.5 is 60 volt. RMS values of the load voltage or output voltage is 60 volt. The next thing we need to calculate power factor. So power factor. So what is the power factor formula? We learned already. In the last class several times we learned power factor is output power divided by V source voltage RMS value, source current RMS value. So this is V means voltage, source voltage, A means currents, amps, so source current. So P0 is what? Output voltage. In your textbook he called this as V0, output voltage RMS value. That's the reason I will use as output voltage RMS V0. Otherwise you can call this, okay, I will separately write. Usually power factor formula is this. What is that? For AC voltage controller. For AC voltage controller, power factor formula is load voltage RMS, or I can say like this, power factor is RMS value of load voltage into RMS value of load current, divided by RMS value of source voltage into RMS value of source current. So RMS values of the load voltage is he called, in your textbook he has called it as V0. Okay, I will also call as V0. Then RMS values of the load current he called as I0. That's the reason I will call as I0. Then RMS values of the source voltage he called as Vs. I will call as Vs. And RMS value of the source current I will call as Is. Okay. We have already calculated V0. What is the value of V0? We have calculated it to 60 volt. So what is I0? Listen here, this is a resistive load. So resistive load. If you plot the current waveform is also flowing in this way sinusoidally. It is flowing like this. Sinusoidally it is flowing. So current waveform is also sinusoidal. It is we should plot it as sinusoidal. Okay, so current is also sinusoidal. Okay, we should plot it as a sinusoidal. Okay, so only difference between the current waveforms and voltage waveform is current waveform peak is Vm by R. The voltage waveform peak is Vm. Only that is the differences. So if we are already having the formula for RMS values of this voltage waveforms, so same formula we can use for current waveforms. Only alteration, instead of wherever Vm is there, we need to change that to Vm by R. Because of that we got we'll get the IO is nothing but IO is nothing but, that is RMS values of the load voltage. RMS values of the load voltage is nothing but RMS values of the load voltage divided by R. That is giving you RMS values of the load current. V naught is already calculated 60, and the resistance value in given problem resistance value in given problem is how much? Resistance value in the given problem is 10 ohm. That's the reason. So that's the reason I will write here. Okay. That's the reason we'll write here I naught as 60 by 10. This is 6 amps. 6 amps. So we'll calculate the power factor right now. Power factor is V naught is 60 and I naught is 6, and Vs is already given 120 volts. Source voltage RMS, source current we have already seen, and I have told already several times. In this only one path is that here our transformer secondary comes here. Okay, so power, whatever power is flowing in positive half cycle, power flows like this. Okay, in negative half cycle, power flows in this way, in this way, in this way. Okay, so but we can whatever we are what is main important here is whatever current is flowing to the load side is coming from the source side. So source load current RMS, if you have already calculated, it is same as the source current RMS. So what I am saying, the load current, if you call this as an I naught, that is an instantaneous value. Using the waveforms of this, if you plot the source current waveforms, it looks almost like this same as load current. Source current waveform is same as load current waveform. So load current RMS, if you calculate, it is same as source current RMS. Because of that, so source current value I will is same as load current RMS. Here I naught comes, actually I naught comes, or else value of I naught you just directly write it is 6 amps. So this 6 cancelled each other. 60 by 120, this is 1 by 2, it is 0.5. So power factor is lagging. So it is over. Then, so what is the next job? He asked us to calculate the average and RMS current of thyristor. We need to say the average value of the thyristor current. He called it as he has not, okay, in the textbooks he named it as IA. You can name as I average of thyristor or IA. Okay, he has, because A means anode, he said anode. Okay, average current of thyristor, any name is okay. Okay, so even you can call this as I average of T. This is also good namings. Okay, we'll see here. See, if current is flowing only in positive half cycle, like in positive half cycle, current, the thyristor T1 is conducting. So current flowing in thyristor T1 is this current, and again this current, and this current. So I can show you with the different color now. So here, so you can see this is, if I plot properly, this is a current flowing through thyristor T1, sinusoidal it is. This is a current flowing through thyristor T1. This is a current flowing through thyristor T1. So during this interval there is no current. During this interval there is no current. So we need to write the average value for the first. We should calculate average value for this waveforms. So it looks like this. It's sinusoidal only. It looks like this. Then 0 because in the negative of cycle. Again sinusoidal. Then 0 in the negative of cycle. Again 0 and negative of cycle 0. So this is sinusoidal. Okay, this is sinusoidal. So this is 0 pi, then this is 2 pi, 3 pi, 4 pi, 5 pi, like this it goes. So then again it is 0 for till 6 pi, 6 pi. So it goes from here to here, here to here. So we should write average formula for this, average value for this. Average value for this. Okay, average value of thyristor T1, thyristor T1. You can call like this thyristor T1 or T. What is an average value of the thyristor T? So average, how much? Here to here. Actually it is, in this case it is 6 pi. 6 pi is nothing but 3 into 2 pi, correct? 3 into 2 pi. Okay, that is on time. Again off time, again this is 2 pi. Total it is 5 pi. So average value in denominator, actually for this I think I should consider this is 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. 10 pi means 5 into 2 pi. What is 5? It is m plus n, nothing but m, total number, m plus n into 2 pi. In that how many cycles are on? N cycles are on. N cycles are on. So then you do that integration for only one cycle because I am multiplying with n. So it is equivalent to, if it is 3, actually I should write 3. If it is 2, I should write 2. So generally I will write as n. So 0, this is 0. This start from 0 here. This is 0. Then till it consists till pi, 0 to pi. What is the waveform? How to mathematically describe this waveform? It is nothing but, it is same as my voltage waveform, but peak is, instead of Vm it is Vm by R. Then variation is sin omega t d omega t. So sin omega t, 0 omega t. So we need to simplify this. Okay, I will write in the next line. Okay, shall I call this as which is a good name? You can call, for me I average of thyristor is a good name. Textbook has called as IA. Okay, I will also follow the same as IA. Okay, so what is that? Previously whatever I will rewrite once. N by m plus n, n divided by m plus n, so into 2 pi. So then integration 0 to pi Vm sin omega t divided by R, Vm by R. So d omega t. If you solve this, you will get average value for this. N, m plus n, 2 pi. This R will keep outside, Vm will write here. Everything will keep outside because they are constants. Sin omega t integration minus cos omega t. limit 0 to pi. So this becomes n Vm by R n m plus n 2 pi. So this minus of cos pi is minus 1, and okay, there is a 1 minus here outside, this because of this. Cos pi is minus 1, minus of cos 0 is 1. So this is minus outside, again inside the bracket minus 2. So Vm by R n divided by m plus n into 2 pi. So this is equal to Vm by R n divided by m plus n this 2 is cancelled, this is minus into minus plus, so they cancel with this. So in denominator there is a term pi. So value of average is Vm. What is Vm value? Vm is nothing but V source volt. Vm is nothing but peak values of the input voltage, that is 120 into root 2. That you please you calculate 120 into 120 into root 2. 120 into root 2. You calculate using calculator. N is how much? N is 25 divided by R is 10, m plus n, m is 75 plus n 75 plus 25 into pi. All of you calculate this. Okay, I will rewrite so smart here clearly if you are having a confuse. So I average of thyristor, you can call this as thyristor, otherwise there is a confuse. Average of the thyristor is Vm by R. So what is okay, I will written already this. Vm by R is 120 into root 2. N is how much? 25. You will get, in divided, R is 10, again m is 75, this is off cycles, again n is 25, then pi. So you will get a value nearer to, in textbook I think he called it as 1.33 amps. You may get nearer to 1.35 amps, it seems. Both are okay, any values is okay. This is average values of thyristor current. Okay. The next we need to calculate, so we need to calculate RMS value for the same current. So we have seen that this in the first half cycle thyristor T1 conducts. So one after zero crossover, in the first half cycle thyristor T1 conducts. from this is 0, this is pi. Again from pi to 2 pi it won't conducts. Then from pi to 2 pi to 3 pi it conducts. And 3 pi to 4 pi it won't conducts. Then 3 pi to 4 pi it conducts. 0 it is. This is 5 pi, like this. Again then later it won't conducts for next several cycles, because if you call m is the number of cycle, on cycle is 3 and off cycle is 2, 5 pi, then somewhere here 6 pi comes, 6 pi, and anyhow for next cycles I said 3 and 2 for next cycles, this is 6 pi, somewhere here 7 pi comes, 8 pi, then again 9 pi, 10 pi. This is my formula, this is my waveforms. The current waveforms, this is, I can say that the current waveform of the thyristor T1. If you take the RMS values for this, here I have called, this is n, 3 is n, so it is 10 totally. Okay, so our general formula, if I write RMS value for thyristor current, so root mean is how much? Mean is m plus n 2 pi. Why? This is 10 pi. M plus n is how much? It is 5. Okay. Then in that how many cycle? N cycles. N cycle is on cycle. Okay. So I'll write n. Okay. Then integration 0 to pi. So mathematical description for this is Vm sin omega t. If this is a current, that's the reason, and divided by R. Then whole squared. Then d omega t. So whole thing if I write here, n divided by m plus n 2 pi. So Vm also I can keep outside, Vm squared, and R I will write outside, R square, R means R squared. Okay, then integration from 0 to pi, 1 minus cos 2 omega t, cos 2 omega t divided by 2 d omega t, that is RMS values of the thyristor T is n by m plus n Vm by R whole square, or Vm squared by R squared, then 2 is also there here. Okay, m plus n, this 2 pi is there, this 2 pi and 2 pi, so this 1 by 4 pi, everything is outside the bracket. Then integration here is 1 integration d omega t integration omega t limit 0 to pi, cos 2 omega t integration sin 2 omega t by 2 limit 0 to pi. Sin 2 omega t by 2 0 to pi. So this, what is this part? n by m plus n Vm squared by r squared 1 by 4 pi. So pi minus 0 pi, sin 2 pi is 0, sin 0 is 0, so it is pi. This pi cancel each other, so Vm by r, you keep it outside. This keep out from the root. Then pi 4 can keep out. So then root of only this remains n divided by m plus n, because 4 root is 2. This is a formula. So what is Vm in our formula and problem? 120 into root 2 divided by 10 ohm 2. Then n is 25, m is 75, n is 25, m is 25. So what is the value? You will get a value very nearer to 1.24 amps. This is textbook answer. You can check whether it is correct or whether the correct answer is nearer to this. This is 25, 75, 25. So in this way we have calculated the RMS values of thyristor current. Okay, thank you.